Jillian Greenbaum proudly presents an introduction to entropy and the universe. You see, a microstate is a very specific configuration that relies on the properties of the smallest element. A macrostate is the big picture properties, and usually several different microstates can create the same macrostate. So let's put some marbles in this box. Let's put 2 red ones over here and then 1 over there. And then let's put a blue one over here and then 2 blue ones over here. Now, this microstate is 1 blue and 2 reds on this side, and then on that side, 2 blues and 1 red. But the macrostate is 3 on each side. Now if we erase the blue one here and erase the red one here, and we just put all reds on one side and all blues on the other, it's a different microstate, but the same macrostate. According to Sean Carroll's book, From Eternity to Here, The Quest for the Ultimate Theory of Time, all possibilities of arrangements of microstates are equally as likely. If I just threw the marbles into the box, there's no reason to think that one of them is more likely to fall in a certain spot than another. So think of this with atoms. Ambiguous atoms are floating around doing what they want, changing microstates all the time. No atom is more likely to be anywhere in particular rather than anywhere else. So for example, a bunch of atoms that are just floating around in the universe could potentially create the perfect microstate to make a bug. No, not that kind of bug. The number of microstates available that creates a macrostate of a Volkswagen Beetle is exactly 1. But the number of microstates that just create a whole random blob of atoms, that's like infinity. So let's just try this out here. Let's take a box. Here's my box. And then inside that box, we're going to put something. There's me. And I am holding a little egg. So we're going to put this egg inside the box. The most common macrostate would just be egg atoms everywhere, because all of the atoms can go anywhere. And it doesn't matter what order they're in or where they are. Remember, the universe doesn't really like order. It's kind of hard to put together. This is called entropy. Entropy is like the randomness of our universe. And we think that it's always getting more and more random. Because of course, order is hard. As I said before, the universe wants to expend the least amount of energy possible, which doesn't involve putting together really complicated structures all the time. So that's the most common, but maybe the next most common would be just random atoms decided to get together and make some bits of scrambled egg. But really, it can be anything. Even, I don't know, a sunny side up egg. So whatever's in the box, you don't know what was in the box just before that. By that logic, if you see a broken egg on the sidewalk, you cannot automatically say that it was recently intact. This is called the past hypothesis. It basically warns us that we cannot necessarily predict the probable past the same way we cannot predict the future. What? That's crazy. Mind-blowing. But wait, why does this matter? Well, practical uses of these ideas in everyday life are laughable. Let's take Steve the postman here. Now, Steve is delivering a very important package. This package is kind of fragile, so he really doesn't want to drop it. Steve knows that gravity works. If he trips, the package is going down. But he needn't worry that gravity may not work one day, or the package may turn into a buffalo, because those things are highly improbable. Ah, run! Steve! We can't just all go through life waiting for our Volkswagen Beetles to drop out of the sky for us. We can't go through life eating our omelets as fast as we can, just in case they suddenly decide to become raw eggs again. So for the layman, this seems totally ridiculous and impractical. And it totally is. But to the physicist who's trying to figure out why our universe is expanding at a rapidly accelerating rate, it's vital to know the laws of physics. And we need to know the laws of physics that seem to exist here may not exist there. That's the royal there, as in anywhere and anytime. In the randomness of our universe, which we can suppose to be infinite, there could be infinite other universes. We have no idea. There must be places somewhere that just don't abide by our laws. We can't even assume that our own laws worked here yesterday. So in this big, bright, beautiful universe, we can't use the past hypothesis to predict the past, and we can't use it to predict the future. We have no idea if everything we believe today will be wrong tomorrow. Anything can change in literally an instant. Theoretical physics is weird, huh?